Hello everyone, we are back with another round of Turing Mock Interview series. I'm Jose, a tech lead at Turing, and today I will be interviewing Jason from the role of an experienced MERN developer, okay? And before you put in the question, as usual, you know, these questions were selected for YouTube purpose. Alright, and to get started this meeting, I would like to ask you to introduce yourself, okay, and tell me a little bit about your background, your experience. Then I'll take from there.
All right. So my name is Chisholm, as you've already stated. I am a full stack developer from Nigeria, which is in West Africa. I have over 3 years of experience working as a full stack developer. I actually started out my career working as a backend developer for a company here in Nigeria, which was also a remote job. So I work using technologies like Node.JS and MongoDB for the database management. Uh, I will later move on to work for an American company, Punch, about a year or so later. There I was employed as a MERN Stack developer, and then I got to improve my skills working on the front end, working with technologies like React and Next.js, Expo, and a lot of JavaScript related frameworks, both on the front end and on the back end as well. And currently I'm working at Turing. So that's basically my professional journey in the tech space.
Nice. So that's great. Okay, thanks for sharing. So let me explain you what we are going to be doing today. Okay, I will split this interview in 3 steps. First, I'm going to ask you a few questions about MongoDB. Okay, then I will ask you Node.js questions and then React.js question. Sounds good?
Good.
Okay.
Yeah.
All right. And apart of MongoDB, do you have experience with any other database?
Yeah, I do. I have experience with SQL databases like Postgres, SQL, MySQL, and MariaDB.
Nice. And my first question is, okay, in your understanding, what's the difference between relational database that you mentioned, MySQL, MariaDB, Postgres, MySQL Server, okay, and MongoDB?
The primary um, difference between the non-relational database and the relational database, basically, so the relational databases are kind of like, as the name implies, structured query language, right? So these are based on tables, right? Data is stored in tables, and those tables have ways of relating them to one another because you need them. You can't store data in you can actually, but as your application or database gets bigger, you need to relate your database with one another, your collections. Let's say you have customers and then you have purchases. You need to find links to these tables. That is basically it. And SQL does that very well by the use of stuff like foreign keys. That way you can point to um, a different table, as opposed to non-relational database like MongoDB, which is relatively newer than SQL databases, right? And they took a different approach. They kind of like use JSON format to store data. And in this offer gives us the ability to cram all the extra metadata that we need to store that is related to a particular document. So we do not always have the need to point to another collection or another database, right? So we can cram all those metadata into an object or store them as an array of objects in the same document. So yeah, that is basically it. And I think non-relational databases offer more flexibility than the previous or the older structured query languages. Yeah, so that's
Nice.
basically it.
Nice. That was great. All right. So, and then you mentioned foreign key, right? So, does MongoDB supporting foreign keys or a kind of things that you can make a relationship between two documents or two records?
Yes and no. Actually, MongoDB does not support the foreign key constraint, because in SQL databases, you have these foreign keys that point to other tables. And let's say if you were to delete a document, you would have to make sure you delete the reference at everywhere it's being used, right? So it's kind of like you have to cascade the whole process. MongoDB is, like I mentioned, it's quite flexible. You don't have the constraint of foreign keys, but you can actually reference a different document in a different collection by using MongoDB's unique IDs, which allows us access to parameters of fields in other documents. It's not quite like your foreign keys do, but it serves the purpose.
Got you. All right. So, and then you said that MongoDB it's based on objects, right? So that's come.
Yes.
My next question is related to that. So, could you please explain the difference, okay, between BSON over JSON, and also what are the advantages to use one another in MongoDB?
Okay, so basically, JSON, which is basically your JavaScript object notation, right, is basically what we use, how we store data or transfer data across the web, right? While MongoDB uses JSON, as you've mentioned, which is kind of like an improved JSON. And the advantages that JSON offers over JSON is that, for one, it's much faster to read and write or access data that was stored with JSON, because you do not, due to the way or the data is being stored, right? You do not waste too much time on encoding or decoding the data, right? It's easier and faster to read. And then you also have other formats available, like date formats, which are not available in JSON format. So these are like the major advantages that JSON offers over JSON.
Great. All right. Okay, and also one big difference, one of the big keys I would say to use a relational database is to use transaction, right? Let's suppose you have a payment system and then you have to remove money from one account and send the money to another account. Okay, use transactions to guarantee that that all of those I'll say script will run in a single transaction, because you don't want to remove money from one account and then save it in another account, right? So how can we achieve transactions in MongoDB? I mean, how can we achieve the same behavior?
Okay, so yeah, because of MongoDB's nature, right? So basically, we are modifying single documents, right? A single document that is the general use case for MongoDB, and on the average, you do not have the need for transactions. But MongoDB actually has a transaction API, which kind of like mimics the transaction that we have in SQL. So we're able to run the same thing, start a transaction, and then terminate it at any point. So MongoDB also has that and offers that API.
All right, and so next question is why is a covered query important in MongoDB? First of all, what's covered query? Okay, and why it's important?
Okay, so a covered query is a query that is successfully run by indexing. So MongoDB does what we call data indexing, right? So it takes like a chunk of the real document, right, and indexes it, so that if we should make a search through the database, it doesn't go through the whole catalog of documents, right? It just goes to the index and checks if the parameter or the search parameters are met with the index. And a covered query is one that actually is successfully met without having to go through to the main document catalog, right? And this is important in MongoDB because it saves a whole lot of time, which of course is very important in the software business. So it makes the queries faster.
Okay, all right. So let me ask you a few questions about Node.js. Okay, so and before we get started, what kind of frameworks, okay, are you familiar with Node.js?
Okay, so I've worked with Express and I've worked a little with Nest.js. These
Okay.
are the basically the two frameworks I've worked with.
Okay, and could you please explain me, just brief, what's the main difference between Express and Nest.js?
Okay, so like one of the main differences between Express and Nest.js. So Nest.js, I would say, is a framework that is built upon GraphQL, whereas Express uses REST protocols. Like you have your GET request, you have your post, you have your patch and your post, and then you have your endpoints, like which are like the what you traditionally know, and you have your middlewares. Make use of middlewares to modify or validate, authenticate requests, right? And then you have your final endpoint. But in Nest.js, it's built upon GraphQL, and then you have functions which serve as endpoints. And then you also make use of decorators, uh, which are kind of cool, a cooler form of middlewares because you can just use, let's say, an auth guard to protect a whole route or a whole line of endpoints, right? As opposed to your middleware. So it's kind of, yeah. So the basic difference is that Nest.js is kind of built on GraphQL. So if you've worked with GraphQL before,
Nice.
it will be very familiar.
Nice. And you
Yeah.
mentioned a lot of cool things, right? You mentioned REST API, GraphQL. You mentioned decorators. That's great. We can pass 1 hour here talking about this kind of stuff. Okay, but I'm going to start with a simple question. Okay, is
Okay.
Node.js entirely based on single thread? Yes.
Yes, the answer is yes. Node.js is entirely based on single thread, even though it's kind of like there's kind of like has a workaround, right? It's kind of runs process in the background, but Node is a single threaded language.
Okay, and what workaround are you referring to?
Okay, so once a request is made, right? So Node.js has like I'll just call it the event queue, right? So let's say if you launch a series of events, it queues them up. And then if the processes are synchronous, which means they're going to take time, it sends them to the operating system to handle it, runs it as a background process. And then it now makes use of a callback system, which means that once these tasks are executed, it gets sent back to Node.js to take it from there. So in real sense, Node.js is not handling the tasks synchronously, but rather it's handing it over, right, to someone else to
Yeah.
handle these processes, but tagging them, say, hey, once you get done with that,
Okay.
send it back my way,
Got you.
right? So yeah, so that's just basically what happens.
All right. So you were talking about the event loop, right? There's a lot of
Yes, yeah.
things. I'll come back with the event loop later on. Okay. But now I'd like to move to the next question. Okay. What is a stream in Node.js?
Okay, a stream is basically Node.js interface for handling streaming data. And streaming data are basically your regular data, but data which are not available at once, right? Which are available in chunks. Yeah, so that's just basically what a stream is.
Got you. And do you know what's the concept of streaming? It's not a
Uh,
question. I'm gonna let you know. Okay. So Node.js streams use the concept of pipe. Okay. And what is pipe? What's pipe? Before I explain, I'm going to let you know. But what's pipe in Node.js or in JavaScript in general?
uh, I'm not sure, but I believe it's kind of like a channel uh, for passing data or something like that. I'm not.
Okay,
Yeah.
that's okay. Okay, it's totally fine if you don't know everything. That's what I expect. Okay, no worry if you don't know how to answer any question. You just let me know. Okay, I might explain you. So the concept of pipe is execute a list of functions. Okay, or could be the same function many times. Okay, let's suppose you have a function 1 that will console log 1, you have a function 2 that will console log 2, and then you have a function 3 that will console log 3, right? So if you implement pipes on that, so you have to create one function and pass a list of functions, okay, function 1, 2, 3, and then when you execute that pipe, it will execute the first function, and the result of that first function will be passed to the second function that it will execute, and then pass the result for the third function. Okay, or it could be the same function and then you can execute that same function as many times as you want. In case of streams, okay, it will execute, it will read the stream in chunks, okay, and then pipe that chunk and then call that function again until it hits the last chunk of the stream. Did you get that? Make sense?
Yeah, of course.
All right, great. So, and so what are the types of streams in Node.js?
We have writable streams, and we have readable streams. We have duplex streams, which are basically streams that offer you the ability to read and write. And then we have transform streams, which are basically streams that modify data streams. Yeah.
Okay, great. Thank you. All right, so next question. Okay, Node.js use V8 engine, right, to compile JavaScript in code, right? And my question is, how V8, okay, compiles the JavaScript code?
Okay, so V8 engine, which is basically the engine that is used by Chrome, by Google Chrome, and then Node.js, actually compiles code by undergoing three phases, right? The first phase is the parsing phase, and at this point, the code is converted or passed into what we call abstract syntax tree, right? And then to the next phase, which is the compilation phase. There are two things that can happen here. You can use an interpreter or a compiler. And an interpreter basically interprets the code line by line and makes sense of it line by line. Whereas with the compiler, it looks at the document as a whole and compiles it into code that the computer understands, basically from JavaScript to machine language. And then it moves to the third phase, which is the execution phase, which is where we have the call stacks and the memory heap. And this is where the code is run. And then if any error should occur, it takes us back to JavaScript.
Nice. That was great, by the way. Okay. All right. And my last question, okay, for Node.js before I move to React.js is, what's libuv and how does libuv work under the hoods?
Okay, so libuv, right? I think it goes back to what I was talking about previously when I was answering the question about if Node.js is a single-threaded language, right? So libuv, I think it's it's a C library. I think that handles these background processes that we've talked about, or handles the background process of Node.js. So this is what takes charge. And it's kind of like you mentioned, the event loop, right? So it's kind of like an event loop where these background processes are going to be run, and it leverages on the processing power of the machine running Node.js, right? And this is where all the stuff are going to happen away from Node.js. And once that is done, it gets passed back by means of callback to the queue stack.
Nice. All right. And before I move to React.js, you are doing great, by the way. Okay. I think this video blow out minds. Yeah. Great. So now let's move to React.js. Okay. And I will start simple. I will start small. Okay. So what is React.js in your understanding?
Okay. So React.js is basically a JavaScript library that helps us build out UI components using JavaScript. So, and the idea is for us to have a single language to rule them all, if I may say. So it kind of works by creating a virtual DOM or a virtual representation of the DOM, right? And then that's what we get to work with. We don't actually work with the actual DOM. And until changes are made to this virtual DOM, that's only when React.js re-renders or forces the actual DOM to re-render, which to reflect those changes. So yeah, that is basically React.js JavaScript framework.
Gotcha. All right. So in JavaScript, we have state and props, right? I'm not going to ask you the difference between state and props. I'm going straight to the question. Okay. How to apply validations on props in React.js?
Okay, so we have what we call React prop types, which is where we declare the prop, basically the prop types that we're expecting, or the types. So it's kind of like TypeScript. So if you're working with TypeScript, you do not necessarily have the need to use React prop types, because you will basically be setting the types of the props and every single thing you're working with. But if you're working with JavaScript, then you might have the need to set this prop type. So if you're expecting a string, if you're expecting a number, if you're expecting an object, you declare those types so that you can see by hovering on the component what props are expected in this component. So yeah, that's basically how we control prop types in React.
Gotcha. All right. And why would you need to bind events, okay, event handlers, to these in React.js?
Okay, so basically, if you're working with class components, right, you have a lot of this everywhere, because you have to reference the main component is the class, right? This is not a problem using functional components in React, though. But so if you are using this in a React class component, then the this you want to refer to is the this, which is the main React component. But inside an event listener, the this, you don't get access to that this. So you have to bind it using JavaScript method for binding this. And it's not only limited to React.js, it's basically in your vanilla JavaScript also as well. If you have an event listener window that don't change or something like that, you would have to bind this or use arrow functions in some cases.
Great. All right. This is one of the cons to use arrow functions, right? So we have arrow functions and then we have functions. And if you use arrow functions, the this will be the color, right? All right.
Yes.
So, all right. So, and what's the difference between use ref and create ref?
Okay. So basically, as the name implies, right, create ref will create a new ref, right? And while use ref will create or use the existing ref. It's kind of like a ref manager. And this is important in functional components, because upon each render, the function is called again, as opposed to what we had before in class components, where you can instantiate a class and the constructor runs only one. So this was not a problem. You could use create ref in class components, and the constructor does not run upon each re-render. So your ref to that particular element is preserved. But in functional components, that is not the case. And that's why we use ref So this this is a hook that allows the ref to be preserved upon each re-render. So that is just the basic difference between use ref and create ref. In functional components, the ref gets created every time the component re-renders. You get a new ref, and with use ref, it ensures that you get back the original ref every time the component re-renders.
All right, so my last question is regarding React class-based components and React hooks. Okay, so do React hooks replace render props and high-order component?
The answer would be no, right? Even though my years of development, I have actually had little to no calls to make use of higher-order components because hooks have been quite sufficient, right? And to a large degree, it kind of like does all you need higher-order components to do. But I would imagine that there are scenarios where you would need a higher-order component. Let's say, for instance, now if you want reusable logic, right? If you want to use the logic of some certain components on multiple components, then you might need a higher order component to wrap the UI part of the component, right? To create the logic and isolate it in a higher order component. But most of the time, you do not need the exact same logic, and then you have stuff like Redux or state managers where you can do some certain form of logic. So yes, it's to a large degree, it replaces it, but not completely. I feel that there's still a place for higher order components.
Nice. All right, and that's it for today. Okay, this is just a sample of the question that you might get if you come to do the interview for full stack developer. Okay, and thank you, Chisom. It was really nice to speak with you today. Okay.
Yeah, thanks, Jose. It was nice to be here as well.
All right, and as that said, that's a wrap for our side. Thank you for tuning in to this mock interview series. Okay, I hope you enjoyed this interview as much as I did, and we'll be back very soon with many more episodes covering different tech stacks and language. And if you are looking for a specific mock interview, please drop a message, drop your suggestions in the comment section below. Okay. Don't forget to give us the big fat thumbs up for this video if you enjoyed it as much as I did. And that's it for today. Subscribe to our channel if you are not subscribed already. It's a red button down below. It's easy, it's free, and it's quick. Okay? Head on Turing.com, create your profile, and apply for the job that are suitable for your tech stack. Until then, I hope to see you all next time.